and welcome to my YouTube channel. So here we are going to be looking at our limiting reagent. So what is the limiting reagent by definition? So the limiting reagent is simply defined as the one that is in short supply of the mole ratio. So as long as a substance is in short supply of the mole ratio, then that means to say it is the limiting reagent. Let's take a very simple analogy. So if we have these people wants to sit, this person would sit, let's say they sit here, this other person, okay, let's begin with the last one. So this person would sit here, this other person would sit here, this other person would sit here, this other person would be able to sit here, but the last person will not be able to sit anywhere because the chairs are done. So in this case you can say that the chairs are the limiting reagents. Now sometimes the limiting reagent may not be as straightforward as you may think. Let's look at this analogy. Let's say you want to make a sandwich. Now for each sandwich you need the ingredients are 2 bread and 1 tomato. So now what you are going to have is this. So in that case, for you to have a complete sandwich, you are going to need just one tomato and 2 slices of bread. Now due to that means to say your reaction is complete. However, let's see what happens if we increase the number of tomatoes containing the bread. Let's advance it a bit. Let's say we have 2 slices of bread, which are these ones. So these are more like, now you have 2 tomatoes. So you will find that you will only need 1 tomato to be put in between the bread. Now what happens to this other tomato? This other tomato is the excess. So meaning to say, for such a reaction, the limiting reagent is the bread. So in such a way, the limiting reagent is the bread, because for you to have a complete sandwich, you need 2 slices of bread like that. So just because in this case, just because we have 2 slices and we also have 2 tomatoes, does not necessarily mean to say we do not have a limiting reagent. No, we do have a limiting reagent. According to this, the bread is the limiting reagent because it is the one that is causing the reaction to stop. So the limiting reagent causes the reaction to stop. So in this case, you need 2 bread, but just 1 tomato. Then the other tomato will be in excess since it won't be used. Let's advance it a bit. So if we look at, let's say you have 3 slices and 2 tomatoes, then you are required to know which one is the limiting reagent. So according to this one, the limiting reagent is still the bread. So bread is the limiting reagent. Though there is more bread, you will find that for you to make a sandwich, you need just one tomato to be on 2 bread. But after doing that, you just remain with 1 bread like that, and 1 bread cannot be used to make a sandwich. So regardless of the situation whereby we have 3 slices but 2 tomatoes, still bread is the limiting reagent like that. So it's very, very important for you to take note of that. Likewise, if you have the third situation, let's say you have 1 tomato there. So what we are going to do is that if we have 1 tomato, only 1 tomato is required for you to make a full sandwich there. Now what happens to the other bread? So in this case, the tomato is the limiting reagent. So the tomato is the limiting reagent. So now according to the Moore concept and stoichiometry, what we have is that we can establish one thing. So what I'm just trying to tell you is that the limiting reagent is not so direct, to the sense that just because you see that this one has got a greater mole, that means to say it is not the limiting reagent. No, it depends with what the equation is balanced with. So in the previous video, we looked at stoichiometry, where the limiting reagent wasn't applying. But now we are looking at questions where the limiting reagent will apply. Now if you look at such type of a situation, as long as you have, so this is how it works. So it means to say for every 2 moles, so according to the mole concept, for every 2 moles of, let's say, bread, you will just be able to react it with one more of tomato. So you can think of it like that. So that means to say, let's say now you have been provided with the bread, to say what if you have 1.5 moles of bread. So if you have 1.5 moles of bread, that would mean, and you still have 1 more of tomato, it simply means to say the limiting reagent in this case is the bread, because you need a full 2 slices of bread for you to make a full sandwich. It does not necessarily mean to say just because the tomato is less in terms of the number, it would be the limiting reagent. No, it depends with the quantitative math that is there. So now let's now look at a question. So yeah, just emphasizing so that you're not confused. If we have we want to create a hot dog in bun, we have, let's say we have 5 sausages and we have 4 buns. Here you can say that the limiting reagent is the bun, because there are less buns, leaving 1 sausage in excess. So the limiting reagent in this case is the bun. So now recall that even if you have the situation of having, let's say, these hot dog buns are separated like that, then you need to put a sausage for you to be able to create a full thing. That does not necessarily mean to say, oh, the sausage is the limiting reagent. So let's say if these 2 buns were separated, so it does not necessarily matter. What we just need is, we need a bun on one side and a bun on the other side for us to create a hot dog. So that means to say the limiting reagent, let's look at it from this perspective. If, let's say, these buns are separated, then for you to create a hot dog, you need one bun, then you put the sausage in the middle. So in total, what we are going to have is 1, 2, 3, 4, 5, 6, 7, 8. 8 buns, but we only have about 5 sausages. So despite having these numbers, we are not going to say that the limiting reagent is the sausages, since they are less. No, the quantitative math has to apply. For 2 buns you need 1 sausage. For 2 buns you need 1 sausage, 1 sausage, 1 sausage. So what happens to the rest? It means to say the sausage, there is an excess of a sausage. That means to say the bun is the limiting reagent. So after this, I don't expect you to fail any question under the limiting reagent. Let's say we have how many moles of iron trioxide can be obtained by reacting 16.8 grams of iron with 10 grams of steam. So now, provided with both reactants, it means to say, for you to predict how much you are going to get, you just don't go direct. You need to know which one is the limiting reagent. So first, the limiting reagent can only be known by calculating the number of moles. So let's look at the number of moles of iron. We know that the number of moles is equal to the mass over our molar mass. Now our mass of iron, according to what we have been given, is a 16.8 grams. We divide by what is our steam. Our steam is equal to, so the molar mass, which is 1 mole of a substance, for iron is a 55.85, like that. So when we divide, we are going to get, so our 16.8 divided by 55.85, this gives us a value of 0.3008 moles of iron, like that. So this is what we have, the number of moles of Fe. Then we are going to find the number of moles of our steam, which is water in gas. So we have the number of moles of H2O should be equal to the mass over the molar mass. So the mass we have been provided with is 10 grams. We divide it by, if we have our H2O, the molar mass will be 16. We add 2 times the molar mass of hydrogen is 1.01 grams per mole. So we are going to have a value that is equivalent to a 16 plus our 2 times, that gives us 2.02, which will finally give us a value of 18.02 grams per mole. So we are going to find that the number of moles of water should be equal to our mass is 10 grams over our 18.02 grams per mole, like that. Then what we are going to have is that we have a 10, we divide it by 18.02, we are going to have a value that is equivalent to 0.555 moles, like that. So these are the number of moles of H2O that we have for such type of an equation. Now let's compare. What do we have? So what we have is, we have 1, it's giving us a 0.3008 moles of our iron. The other one, it's giving us 0.555 moles of our water. So now if you look at this, it is not so direct to say, it is not so direct to conclude that water is the limiting iron is the limiting reagent. It's not so easy as. So what we have is this. So now, for us to determine which one is the limiting reagent, we can be able to compare with what we have been provided. So what we have been provided says that we have this. So now what you can just do is go for the one that you suspect to be more like the limiting reagent. So what you are going to say is that according to the balanced chemical equation, the Moore concept tells you that the equation gives you that if you have 3 moles, you can react with 4 moles. So you can be able to say 3 moles of your iron can be able to react with 4 moles of water, which is our H2O, like that. Then you ask yourself, what if I have 0.3008 moles? How much of the substance do I expect to be able to react? Because according to the equation, it gives you that the reaction is a 3 to 4. Then go for the one that you suspect to be the limiting reagent and find out if it is truly the limiting reagent, because you can't know direct, just as those examples that we were given for bread slice and all that. You are going to say x. We are going to cross multiply. We are going to have our 3 times x. It will be our 3x should be equal to, we have a 0.3008. We multiply times 4 moles of what we have is our H2O. So this tells you that this 0.3008 can react with, we can now be able to divide over 3 over our 3. We are going to have our x to be equal to, we have our 0.3008 times 4. That value gives you a 1.2032. You divide by 3, you are going to have something that looks like, so divide by 3, you are going to have a 0.401 moles of what substance is this? So we have water there. So we have water. But as you can see, the amount of water in terms of moles that was used is a 0.55 moles. Now the limiting reagent tells you to say as long as, so in other words, this 0.3008 moles can, this 8 moles of the ion can only be able to react with 0.401 moles of H2O. But remember, there is 0.555 moles. Now the way it is, as long as all of this reacts with that, it means to say the reaction will stop. So meaning to say, from here you can establish to say ion is the limiting reagent, because it can only react with 0.4, but the available is more. So meaning to say there will be more that will be left, just as our bread and slice and the sausage was concerned with our example, is the limiting reagent. Now let me show you a simple way of determining the limiting reagent, but you can just show this for the sake of marks. But before you do this, to know which one you are going to suspect to be the limiting reagent, this is what you do. So what you can just do is get the 0.3008, then divide this value by what number is in front of ion. So this is for ion, so therefore you go for what number is in front of. So the number in front of ion is a 3, so you are going to put 3 here. So you are going to say a 0.3008, you divide it by 3. This gives you a value that is equivalent to a 0.1003 moles. Then look at the steam. You are going to write your 0.555. You divide it by the 4 that is there. So we have a 4 there. We are going to have a value that is equivalent to, so 0.555 divided by 4. This gives us a value that is equivalent to a 0.13875. So just by doing this, you can be able to determine which one is the limiting reagent, whichever is smaller, after dividing by their coefficients. Then that means to say it is the limiting reagent. So in this same way, we can be able to say that ion is the limiting reagent. So if ion is the limiting reagent, it means to say it is the one that is in short supply of the mole ratio. Therefore, it is the one that you are going to use to determine how much products are going to be more like evolved, because it is the one that will cause the reaction to stop. So now you can just do this, then just compare. If you are told to show the limiting reagent, and just compare like this, say 3 moles of iron should be equal to 4. Then here you are going to put which substance. If you know to say this substance is the limiting reagent, you are going to put the value, that the actual value that you have. If iron was the limiting reagent, we could have put the iron there. So it's very easy for you to determine the limiting reagent using this, then use that to test. Now let's find our mass. We are told how many moles. In fact, we are told how many moles of iron trioxide can be obtained by reacting 16.8 grams of iron with steam, like that. So let's be able to answer that. So knowing the mole concept, it tells us that as long as so we compare with the limiting reagents. The limiting reagent is the iron. So according to the mole concept, it tells us that as long as you have 3 moles of iron, you are always going to get how many iron trioxide, which is this one. You are always going to get 1 mole. That's the quantitative part. You should watch the previous video if you do not know how to do this. So 1 mole of Fe2 or Fe3 or 4. Then you are going to have, what if you have a 0.3008 moles of iron? So you only compare with the limiting reagent because it's the one that will cause the reaction to stop. You cross multiply we are going to have so as long as they are on one side, we are going to cancel them. So 3 here it was more, so you can, so 3 times x, it will be 3x should be equal to 0.3008. You multiply by 1 more of our iron 3 oxide, like trioxide, like that. So we are going to have, we divide by 3, the value that we are getting is our x should be equal to, we have a 0.10 so 0.3008 divided by 3. This gives us a value that is equivalent to 0.003, like that, moles of iron trioxide. Let's look at this question. It says copper 2 nitrate can be produced from the copper 2 chloride by reacting it with a solution of sodium nitrate, resulting in the formation of copper 2 nitrate and sodium chloride, like that. Then we are told for the first part, write the balanced equation for the reaction. So remember, without the equation being balanced, there's nothing you can do with the more concept. So you react copper 2 chloride with sodium nitrate. So what we have is copper 2 chloride, which will look like this. We add plus our sodium nitrate, like that. Then what are we going to produce? So we are producing, so these interchange, so the nitrate and the chloride interchange places. So we are going to have our copper 2 nitrate, which will look like this. Then we have a 2 there. Then we are going to have plus. We are going to have our sodium bonded with chlorine, like that. Remember, the valency of sodium is just 1, so it will just be NaCl, like that. Then from there we are just going to balance. So to balance this equation, we are simply going to add a 2 here. So we put a 2 here, we put another 2 here, then our equation is balanced. We obtain our 2 marks there. Then here it says that what is the limiting reagent for the reaction. So what we are going to do is, let's find how much moles of it are there. So according to the question, we have 15 grams of copper 2 chloride, and we also have 20 grams of sodium nitrate. We are trying to find out which one is the limiting reagent. So using the moles, first let's find our molar mass, or our number of moles. First, let's find our molar mass. So CuCl2 will be equal to, we have the molar mass of chlorine, it's 35.45 grams per mole. Then we multiply this value, since there are 2 of them, by 2, like that. Then we have the molar mass of copper is 63.55. So this is our mass, grams per mole. So we can now multiply our 35.45 times 2. This gives us a value of a 70.9. Then this other one, it's a 63.955. Then we add them. We are going to get our molar mass to be equal to 70.9 plus 63.55. We are going to get a 134.45 grams per mole. So remember, the molar mass is the mass of 1 mole of a substance. So that is very, very important information. So it doesn't matter what number is here, you just consider one thing. So we are just going to have let us find the number of moles. So the number of moles is equal to the mass over our molar mass. So our mass, according to that, is 15 grams. We divide by our molar mass, which is our 134.45 grams per mole. We are going to get a 15 divided by this answer, this gives us a value that is equivalent to 0.1116 moles, like that. Then we are going to look at the other thing and find out how much moles does it have. So before that, have we interchanged them? No, it's okay. So let us find the molar mass of sodium nitrate. So oxygen 16 times that's 3, nitrogen 14 point, should be our 0.01. Then we have our sodium, it is equal to 22.99. so all these are grams per mole. You can write grams per mole. So we are going to get a 48 here, we have a 14.01, we have a 22.099. so when we add this, we are going to get a 48 plus 14.01 plus 22.99. this gives us a value that is equal to 85, like that, grams per mole, like that. So this is our molar mass of sodium nitrate. From there we calculate, so our number of moles is equal to the mass over our molar mass. So our mass is equal to, we have a 20 grams, then over our molar mass, which is our 85 grams per mole. So we are going to have 85 grams per mole, like that. Then when we divide our 20 divided by our 85, we are going to get a value that is equivalent to 0.2353 moles, like that. So these are the moles. These are the moles of NaNO3. So these are the moles that were used. So now let's compare them. So continuing our equation, we have copper chloride. We had 15 grams, which is now found to be, in terms of moles, this is equal to 0.1116 moles. Then we also have found that the moles of sodium nitrate present in this is equal to a 0.2353 moles. So what we are going to do is, as we can see, our copper 2 chloride, there's a 1 there, so we just divide this 0.1116 moles, we divide over our 1 mole, like that. It will just be equal to whatever we have. It is still a 0.1116 moles. You compare it with this other substance, it is 0.2353. You divide it by 2, we are going to get a value that is equivalent to 0.11765 moles. So by doing that, you can directly compare which one is the limiting reagent. So whichever is smaller, that's the limiting reagent. So now what you can do is that you just compare, since you know that this is your limiting reagent, using the other way of comparing, what we can say is, from the equation, 1 mole can be able to react with 2. So we are going to say 1 mole of our copper 2 chloride can be able to react with 2 moles of our sodium nitrate, according to the equation. Then we are going to say, how about if you have 0.116 moles? How much of it can it react with? You are going to say x. You cross multiply, we are going to have so CuCl2. So this and this goes. So we are going to have x times 1. It will be, x should be equal to 2 times our 0.1116. We have the moles of NaNO3. So what this tells you is that it's more like you're trying to find how much can it react with, which we can use later. So now when you do this, we are getting a value of 0.2233 0.2 moles of sodium nitrate. So that means to say the number of moles of 0.1116 moles can only be able to react with 0.2232 moles of sodium nitrate, like that. So then what this means is that what was the actual value that we found? So the actual value that we found was at 0.2353. So we have a 0.2353. So as you can see, this amount that is available is too much. If the amount that is available can only react with 0.22, which is smaller than this, it means to say copper 2 chloride is the limiting reagent. So we can conclude to, so already just by doing this, just by dividing whatever number is in front of that, you can be able to determine direct. So as you saw here, we have a 0.1116. This is 0.117. So this one is bigger after dividing it too. So whatever is bigger, that's the one that is in excess. Whatever that is smaller is your limiting reagent. So that is how we can go about. If they ask us to say how many grams of copper 2 nitrate is formed. So to find out how many grams of copper 2 nitrate is formed, we are going to use which one is the limiting reagent. If we remember, our limiting reagent is our copper 2 chloride, which is equal to, we are having a 0.1116 moles of copper 2 chloride. So we can only use the limiting reagents to predict what we are going to get. So we have how many grams of copper 2 nitrate is formed. So provided with the limiting reagent which we have found, we can compare. So from the balanced chemical equation, we say as long as I have one more, according to the equation, one more of copper 2 chloride, I will always be able to produce one more of copper 2 nitrate, like that. So that is the balanced chemical equation. So we are going to say the number of moles. So one more of our copper 2 chloride will be able to give me one more of CuNO3. That's according to the balanced chemical equation. Then we are going to say, how about if you have a 0.1116 moles of CuCl2? So this and this cancels. Here we are going to have x. So crossing multiply x times 1, it will be x should be equal to 0.1116 times 1, it will be 0.1116 moles of CuNO3, like that. So this is what we have, like that. So if this is what we have, then what we are going to have is that we are going to find the number of moles, or the mass now, since they want us to find how many grams of this is formed. So we are going to say the number of moles is equal to mass over the molar mass. So the mass should be equal to, we have mass times 1, it's mass. Then we have the number of moles times the molar mass. Then what we are going to have is the copper 2 nitrate, like that. Then we are going to find the molar mass. So already we are going to say the molar mass of oxygen is 16. We are going to put the grams per mole times the number that is there is 3, then times this 2 that is outside. So we are going to have our 16 times 3 times 2. This gives us 96. Then we go to our nitrogen. Our nitrogen has got the molar mass of 14.01. We multiply by the 2. The 2 multiplies everything. We are going to have 28.02, like that. Then what we are going to have, Then our copper has got the molar mass of 63.55. So we are going to have 63.55. Then we add them. So what we are going to get is 96 plus 28.02 plus our 63.55. This gives us a molar mass that is equivalent to 187.57 grams per mole. So that's per mole, and this space has run out. So we are going to have our number of mole, our mass. We have said that it is equal to the number of moles times the molar mass, and the number of moles is equivalent to 0.1116 moles. Then we multiply this by the molar mass, which is 187.57 grams per mole. Then what we are going to get is, when we multiply this value by 0.1116, we are going to get a 20.933 moles, like that. Sorry, not moles, but grams. So this is the mass. So for our fourth one, it's saying that how many grams of the excess reagent is left over in this reaction. So to find out how much of it is left over, what you're going to do is that you're going to find out how much can your limiting reagent react with. So firstly, we have 0.1116 moles of copper to chloride. Then the amount that was used for sodium nitrate was this, which was NaNO3, like that. So now we need to know how much can this react with. So the equation says that 1 mole can react with 2. So we are going to say 1 mole of our CuCl2 can only react with 2 moles. That is from the equation that is balanced. Then we are going to say, how about our 0.1116? How much of it can be able to react? So we are going to say that. So we are going to say x. We don't know how much it can react with. We are going to say cross multiply. So x, this and this on the same side can cancel. X times 1, it will be x, should be equal to, we have a 0.1116 times our 2 NaNO3. Then we are going to have, when we multiply this, 0.1116 times 2, this gives us a value of 0.2232 moles. So that means to say your NaNO3. So that means to say, out of the whole amount, the 0.1116 moles of CuCl2 can only react with 0.2232 moles of our NaNO3. So with this established, we can now use this value to determine how much of the excess mass was remaining. So we are going to say, to find the moles of remaining will be equal to the moles of excess minus the used. So that means to say, out of all this, the only number of moles that was used was a 0.2232. So we are going to say the biggest mistake that someone would make is to just go direct to subtract the 0.1116 minus the amount that was available, which was a 0.2. What was the amount that was available? The amount that was available was a 0.2353, like that. So you can't subtract direct, because this equation, according to the equation, it's saying that 1 mole of copper to chloride can be able to react with 2. So already your equation is saying that one can be able to react with 2. So you cannot necessarily just subtract to say this amount of moles minus the amount minus the 0.1116 moles. You can't do this because already your equation is telling you to say just 1 is able to react with 2 like that. So therefore you need to know how much the 0.1116 reacted. Then whatever you are going to get, you subtract it with the moles of the excess. So the moles of the excess is such that it is equal to 0.2353 moles. So we can just subtract minus our 0.2232. So out of this, the amount that was used was this. And this was the amount that was used. We can just put the moles out there. Then when we subtract minus our 0.2353, this gives us a value that is equivalent to 0.0121 moles like that. So these are the moles of the remaining. So these were the moles of the remaining. Now, regardless of the situation whereby they are still the moles of the remaining, it is still the same compound, which is our sodium nitrate like that. So therefore, what we are going to do is that to find the mass now, we want the mass of the excess. Let's find the molar mass. I believe we have found this, which is a 3 times 16. We have a 14.01. We have a 22.99. So when we add this, we have a 48, we have a 14.01, we have a 22.99. So when we add this, we were getting a 48 plus our 14.01 plus our 22.99. We got the value to be 85. So we are going to use our 85 grams per mole. So what we are going to say is that the number of moles is equal to the mass. According to the formula we've discovered, we said mass is equal to the number of moles times the molar mass. So our number of moles is equal to the remaining. So to find the grams of the remaining, we can say the number of moles of the remaining times the molar mass like that. The molar mass is fixed, remember. So we have the number of moles is 0. The remaining was 0.0121 like that. Moles times the 85 grams per mole like that. So these were the moles of the remaining. Then we are going to just cross multiply. We are going to get a 0.0121. Then we are going to have times 85 like that. So the value it gives us is equal to a 1.0285 grams. So this was the grams that was remaining. Let's look at our last question. It says, if 11.3 grams of sodium chloride are formed, what is the percentage yield of the reaction? So this is very, very simple. So knowing fully well that the percentage yield is more like what percentage do you have out of the whole thing. So the percentage yield is given as the actual, which is the actual yield over the theoretical yield. So we have the theoretical yield like that. Then we multiply this by 100%. So now the theoretical yield can be able to be obtained from a reaction. Now we know to say the theoretical yield is not actually what you evolved in the reaction, because sometimes you might predict to say, maybe let's talk of business. If you're selling each item at let's say each item is costing let's say 20 kwacha like that. So each item you sell is 20 kwacha. But let's say if you have 4 items, the amount that you are expected to have is 20 times 4, which will give you 80 kwacha. Now this 80 kwacha is the theoretical, that's in calculations. Now let's say, for example, in this same 80 kwacha that you were expected to have, so let's say, yes, one, in a business you are going to sell it at 20 kwacha each item, but because this person is buying a lot, they say, no, I want discount and I'll get a 15 each. So you will cross multiply and say 60 kwacha. That is the amount. So this was the theoretical, the actual was 60. So to find out the percentage yield, it means to say you have to divide 60 over your 80 times 100% to find out how much have you yield from what you expected to have. So this is just a 75%. So this is the same principle with percentage yield. It's not every time that the reaction, each and everything, will be able to be finished to completion because of maybe some human error, spillages, improper calculations in terms of weighing and all that. So there are a lot of things that limit the reaction. Therefore, the actual yield should be it is given, but the theoretical yield can be calculated. So using your theoretical, using your what's this, limiting reagent. So the limiting reagent was copper 2 chloride there. So we are going to say, according to the equation, the limiting reagent is this. So according to the equation, let's find out how much mass are we expected to have. So we are going to say, if we have one more, we expect to produce 2 moles of sodium chloride. So we said 2 moles of sodium chloride, like that. Then what if we have the 0. The one we found 0.1116 moles. Then what we are going to have is x there. So we are going to cross multiply. X times 1, it will be x should be equal to 2 times 0.1116 moles. So doing this, we are going to multiply there. We are going to have a 2 times 0.1116, like that. So when we do that, we are going to find that the number of moles that we are going to find is a 0.2232 moles of sodium chloride produced. So now what we are going to end up with is let's find out what is the mass of this. So the mass is equal to the number of moles times the molar mass. So the molar mass of sodium chloride is 35.45. Then we have 22.99. If we add our 35.45 plus our 22.99, this gives us a value that is equivalent to 58. So 35.45 plus 22.99, this gives us a value of 58.44 grams per mole, like that. So our number of moles is found to be a 0.2232 moles. Then we are going to multiply by our 58.44. You can just add grams per mole. Now for me it's just space. So when we multiply this, we are going to get a 0.2232. So we are going to get a value as expected to be 13.04 grams. So this is, according to the calculation, this is what we expected to have. So to find the percentage yield, we are going to say percentage yield should be equal to the actual yield over the theoretical yield times our 100%. So what we are going to have is our actual is 11.3. According to the question, we are given as 11.3 grams. So we are going to say 11.3 grams over the theoretical, which is 13.04 grams, like that. We multiply this by 100% like that. So what we are going to have is 11.3 divided by 13.04. What we are going to get is, when we multiply by 100, we are going to get an 86.7%. So we are going to get 86.7% like that. So this is our percentage yield like that. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.